Hey guys, welcome back. We're continuing on solving double integrals over non-rectangular regions. We are now going to do an example where we are called type 1 regions, where we're asked to evaluate a double interval where we're evaluating the function x of dA, where d is the region bounded by the curve y equals x squared and the line y equals 2x plus 3. So this is the very first example where we're not actually given the bounds, so we actually have to find them. One thing that we also want to take into account here is whether it should be in terms of x or in terms of y. One of the things that I talked about back in my AB and BC lessons is the fact that it's nice for us to go in terms of x, just because any rectangle that you draw in this region, the top function is always going to be the 2x plus 3, and then the bottom function is always going to be y equals x squared. So this is actually going to be one of our bounds. So the other one is we got to figure out where our x values are, right? So since this is a y and a y, that will be our change in y. So all we have to do to find the other bounds is just set the two functions equal to each other and find out where they intersect. So we get x squared minus 2x minus 3 is equal to 0. And we do a quick factoring. We're obviously going to see that one of them is positive and one's negative, right? And so we're going to get 1, we're going to get 3, and we're going to get the fact that we get bounds at x equals -1, and then they intersect at x equals positive 3. So what we can now do is realize that our bounds on the left and the right, or in terms of x, is going to be -1 and positive 3, and then our y bounds are going to be the function in the top of 2x plus 3, and in the bottom, y equals x squared. So one thing that we kind of want to do here is to kind of figure out, okay, what order we want to do them in, right? Because we can choose whatever order we want. So since I have an x here, why not do it in terms of y? And the reason that I want to do that is because we want our functions. So we always want our constants to be on the outside. So this has to be the constant. So obviously the easiest choice here is that x has to be our outer bounds because again, we always do constants at the end. So in this case here, we could rewrite these and do a region 2 where we get things in terms of x, and then we would do our bounds here with respect to y. So since this is much easier for us to have constants as our x's, our outer bounds is going to be -1 to 3, and that means that our y bounds are going to be just like before. Our top curve is always going to be our top integral. So in this case here, in that region, our top is always going to be the line 2x plus 3, and then our bottom region is going to be our bound for the lower bound, which is going to be x squared. So again, just a friendly reminder that when you're doing these setup problems, that this outer bound is always going to be constants and the functions are going to be in the inside. So that's going to be our region, and then we're going to keep the function that we have here as x, and then remember we did this with respect to y, right? These are y equations, and then this is x equals 3 and x equals -1. So in previous videos, we've actually given this to you, right? This is where we've started, but now, and it's pretty easy to do, right? You guys knowledge from your AB and BC calculus classes, just draw your region and just kind of visually see what's going on here. So let's go ahead and start doing this. We've done it before. Let's integrate from -1 to 3. We're going to integrate x, but again, friends, in terms of y, right? So x is a constant. So we're just going to do the integration of x as xy. And we're going to evaluate this from 2x plus 3 and then x squared dx. All right. And then just like before, we're going to take all of this equation and we're going to replace it with y. So let's go ahead and do -1 to 3. And then what I'm going to do here is I'm just going to put parentheses around this for a second so we can just see what's going on. So we're going to do a 2x plus 3 minus x again. And we're going to replace this with an x squared dx. Okay? So again, we're not doing anything with the x's. We're just plugging right into our y value. And then we're going to do a quick little simplification here. So -1 to 3. We get a 2x squared plus 3x negative x cubed dx. All right. And then we just start integrating again with respect to x. We're back to a very simple problem that we've done in previous courses. So when we integrate, we get a 2x cubed over 3 plus 3x squared over 2 minus x to the 4th over 4 evaluate it from -1 to 3. And we're going to save a lot of time and energy here. We would plug 3 into all our functions, and then we plug in -1 to all our functions. You guys know this already, your multivariable calculus, so I know that you guys know how to finish the problem up. The point that I just want to make here, and what really the video is for, is just to make sure that you guys feel comfortable setting the integral up correctly, and then making sure that you remember what's a constant, what's a variable here. So again, I will say that whenever you're setting up your integrals, that you always want to make this first integral, the outer bound integral, constants, and then your inner integral are going to have functions to it. All right. So what I'd like for you to do, if you can, is to look at example number 6, pause the video, and see if you guys can at least set up the integral. Maybe draw a picture. I always think drawing pictures are really helpful for this region. And then go ahead and evaluate if you can. So pause the video here and set it up, solve it if you can, and then push play, and we will go over how to solve the problem. Okay? All right, guys, so I went ahead and drew the little picture over here very poorly. I apologize again for my drawing here, but I went ahead and drew this. I would actually talk about how to set this up before, and then you can pause again to solve it if you need to. But I went ahead and graphed the two functions. So the pink line is y equals 1/2 x. Then the brown equation here is y equals the square root of x. You can see that setting them equal to each other, you will get that they do intersect at y equals 4, right? So square root of 4 is 2, and then 1/2 of 4 is also 2. So they have an intersection at 4, and then they're also bounded by the line x equals 2. So hopefully this is pretty clear for you guys to be able to set this problem up, because since my bounds, right, my bounds for the x, my left and right are both constants, that's where I'm going to start, right? So I'm going to get a 2 and a 4 as the bounds for my region, and then I'm going to go ahead and bound it again, and then just like previously, the top function is going to be the upper bound, which in this case is going to be the square root of x, and then my lower bound is going to be 1/2 x. All right, and then we're going to take whatever the function is given to us as. So this is going to be our x and our y, and then we're going to go, remember this is y equals, so we'll do with respect to y first, and then with respect to x. All right, so hopefully that makes sense on how we set the problem up. Now, if you need to continue on, pause the video, solve the problem, and we'll come back here in a second to finish this problem up. All right, guys, so I went ahead and finished out the problem for us. So just look at this quickly and see that we started our problem right here in the red. We went ahead and integrated our y, which is y squared over 2, and then we evaluated from the square root of x to 1/2 x dx. Here in the blue, we just plugged in. So I did pull the 1/2 out. I left the x on the exterior. I pulled in the square root of x right here, squared it, and then minus, oh, that should be a negative. So let me fix that for you guys right now. Don't know why I put that as positive. So it's always nice to go back to my little work here. All right, so minus. All right, so minus 1/2 x quantity squared dx. I went ahead and did some simplification. So the square root of x squared is just x. So x times x is x squared. I get 1/2 x quantity squared, which is 1/4 x squared, times x is negative 1/4 x cubed. I then went ahead and plugged in 4 to my integration of x cubed over 3, and then x4 over 16. And when I plugged in, I went ahead and did 4 cubed, which is 64 over 3. And then what I did is I did 4, because I didn't know what 4 to the 4th was without a graphing calculator. So I realized that, well, 4 squared is 16, so I'm just left with a 4 squared over here. And then minus 1/2, plugged in my 2 to both my functions, and yet again, I have forgot the 16. I must have done this really quickly. And then my final answer is 343 over 12. So again, the point that I really hope that you guys get out of the video is really just how to set the integrals up. And then again, remembering what is constant and what is a variable here. So once you get to this step right here, which is funny enough, we're making this my mistakes, is actually just basic BC or AB calculus material. So anyways, here is your video. Hope that made sense to you guys, and I will see you in the next one. Take care.